Hi there, welcome back to the Python Mastery Crash Course. I'm Gority Golden, and today we are going to master functions in Python. Functions are a fundamental concept in programming, and understanding how to use them effectively is crucial for any aspiring developer. So let's dive right in. So a function is a block of code that can be executed multiple times from different parts of your program. And functions help you organize your code, reduce repetition, and also make your programs more modular and reusable. In addition, functions are generally used to perform a particular task. So to define a function in Python, you use the def keyword, then followed by the function name. And you also have to ensure that the function name must be in line with the naming conventions of variables. So that means that the function name can be created in snake case, camel case, or the Pascal naming convention. So for example, let's say that you want to create a simple function that returns your name. So in this one, the function name can be my name, and then you follow it up with the parentheses. And also, depending on the needs of your program, you can always pass in parameters, and we are going to understand what parameters are later. So you can always pass in parameters, or you can let them be empty, meaning that they're always optional, they are not always required. Then you have to follow this up with the colons according to the syntax, and then within the function definition, just this other space, you always have to go ahead and provide the statements that the function is going to use to perform its task. So since we want to go ahead and create a simple function that returns a name, that means that for now we can just go ahead and work with the print function. And within the print function, you can always work with the f-string formatter. Then you can go ahead and have a simple statement like my name is. Then you can just go ahead and work with the exact name. Or sometimes, instead of having the name statically passed in, you can always create a variable. And we are going to understand more about variables in terms of the local variables, and then the global variables in terms of the functions. But what you have to know for now is that functions always work with local variables, and these are always variables that we define within the function definition, and they can only be accessed within a function, unlike the global variables that can be accessed even outside of the function definition. So in this one, for example, you can have a local variable which is name, and you have to ensure that the variable name is not the same name that has been assigned to the function name. So name, then you can go ahead and assign it a value like Gority. And now instead of statically passing this one, this other name here, you can work with the curly braces, and then you pass in the variable, as simple as this. Now let's look at calling a function. So I'm pretty sure that maybe if you're a beginner, the first time you heard about calling a function, you actually thought that you are going to hold your phone and maybe try to make a direct call to a particular kind of function, or just like the way you always work with people in a way that you want to call someone directly. So in this one, we are not really focusing on the direct calls that we always work with. In terms of this context, we have seen that a function is always used to perform a particular task, meaning that for it to be able to execute the instructions within the function, you have to call the function. So in this context, calling a function is just ensuring that the function is executed. So for you to achieve this, you simply type the function name followed by a list of arguments. That is, if the function was working with parameters, as we are going to see. And simply put, the fact that we are not working with parameters in our current function, that means that the way we can call this function is by accessing the function name, and then we pass in the parentheses. So whenever you're calling a function, you have to also ensure that this call is not within the function definition. So for example, if I go ahead and cut this and paste it within the function body in here, this is not allowed. When you look at recursion in the future, you're going to realize that this is going to be a recursive operation. So the best way to work with this is to ensure that you always move out of this function definition. And also sometimes you would forget and, for example, bring the variable name on the starting line. That means that you're going to have indentation errors. So you always have to take note of that. So whenever you're calling the function, you ensure that you're moving out of the function definition or the function body, and you go ahead and paste this here. So the function body or the function definition is this scope in which we are defining the variables which are always local, bounded within this function, and also the statements that the function is going to work with to perform its task. So while calling the function, this is what you always have to do. You just have to access the function name, and then you go ahead and work with parentheses. And since we are not working with any parameters, that means that we are keeping the parentheses empty. Having discussed that, we can now go ahead and test out our function. So by ensuring that our program is executed, you go ahead and access the Python command, and then our file is functions.python. Then you press enter. So you can see that our program is being executed. So the fact that we do have a function call, it goes ahead and executes this function such that we are able to see the output. And as you can see, the output is my name is correct. So initially I had talked about the local variables, and furthermore, you have to understand that the local variables are the variables that are defined within the function body or the function definition. So just like we do have this current function, you just have to take note of the fact that for any variable that you define within the function definition, it makes it a local variable. So for example, let's say that you want to create a simple function that calculates the sum of two numbers. So the first thing that you have to do is to access the def keyword, and this is used for the definition of the function. And having defined that, we go ahead and pass in the function name. And in this one, the function name, you just always have to ensure that it is in line with whatever you want to achieve. So if it is calculating the sum of two numbers, so we can just have this sum of numbers. So the choice on which naming convention to work with is always yours, but you always have to ensure that you are consistent. So you can see that currently this other naming convention is the camel case, and for that case I'm also keeping this one to be consistent like the other. So sum of numbers, and you go ahead and pass in the parentheses and then the colons. So in terms of the sum of numbers, you have to know that this function is going to be used to calculate the sum of two numbers. So that means that one, in terms of the local variables, we are going to keep track of the variables. So for example, we want to calculate the sum of 150. That means that the first number is going to be 100, and maybe the second number is going to be 50. So the values 100 and 50 require variables to be stored. So the first thing you have to do is to define what we call as the local variable for each value. So we can have local variable names like num1, and this is going to be assigned to 100. And we can also have another variable name called num2 such that this is assigned to 50. So in terms of this function, you have to keep in mind of the expressions in Python, and not only in Python but also other programming languages. So in terms of expressions, you have to keep in mind on how we work with arithmetic operators, because you know that if you're to sum up two numbers, you have to go ahead and work with the addition operator and be able to find the addition of these two numbers. So that means that we need, for example, a variable that is going to store the final result, and the final result is going to be the summation of num1 plus num2. So you can see that whenever you do access these local variables, the color changes. The color is changed to this other brighter blue, and as you can see, the result variable is still in the light blue color. That is because of the fact that we haven't made use of it. So having created the expression which is on line 20. That means that one, we can actually work with a print statement, or you can also always work with a return value, as we are going to see in terms of the return values. So for now, we are going to keep it precise and go ahead and work with a print function that is going to go ahead and return a customized output for the summation of these two values, such that we can say that the sum of these numbers, so you can always access them within using the curly braces, the sum of num1 and num2 is this much. Then you can always pass in the result. So you see that having passed in the result variable, it also changes the color. Having completed that, we can also try to execute this function by calling the function. So for now, we can comment out the first call of this function such that we only focus on the output of this function. So just like we did for the first call, you only have to access the function name and then you pass in the parentheses, and this only works if you haven't worked with parameters, as we are going to see with time. So for now, this is it, and I'm now going to go ahead and call up this function. So you can see that we are having the output as the sum of 150 is 150, which is true. So that means that variables num1, num2, and lastly result are local variables. So these are local variables because of the fact that they're always defined within the function body or the function scope. So what does this mean? It means that if you went ahead and try to access, for example, let's say that you want to print the value of num1, which is 100, by accessing this value as num1. So you can see that at this time when I try to access the variable num1, it's actually not defined. This is because of the fact that it is bounded, it is local, it is only accessed within the function body. So if you really wanted to work with variables in a way that you can always access it even outside of the function, that means that you have to go ahead and define what we call as the global variables. So the global variables are those variables that you can always access even outside of the function bodies. For example, if you have a variable that is going to store your current age, when you try to update this from num1 to age, you can see that we are still accessing it. And it is also the same case if we really wanted to make use of it elsewhere. For example, instead of just printing the name, we can also have this updated to my name is this and I am this much old. So you can see that when I actually pass in the age variable, the value will also be accessed. This is because of the fact that the age variable is global, meaning that it can be accessed within the whole program. So it's not only bounded to the function body or the function definition. So this can be and I am 24 years old. So now let's look at the function parameters and the function arguments. So most times there is a confusion between the parameters and then the arguments of a function. So what you have to keep in mind is the fact that the parameters are always the variables that are defined in the function definition. And on the other hand, the arguments are always the values that are passed to the function whenever it's being called. So for example, if you wanted to create a function that calculates the area of a circle, the first thing that you would do is one, defining the function by accessing the def keyword and assigning it a function name. For example, area of a circle. And then you always have to follow it up with the parentheses. And for you to be able to work with parameters, you have to keep in mind that the parameters are always passed within the function parentheses, these. So you also have to know that the parameters are always user defined as long as they also follow the variable naming convention, and you can always have more than one parameter. So in this one, if we are to calculate the area of a circle, that is going to be a formula of pi r squared. So realize that for you to work with the expression of calculating the area of a circle, you always need the radius. So that means that in this context, the radius is going to be the parameter, and therefore you can pass in the parameter as the full name of the radius, or sometimes you can choose to work with the precise approach by just passing in r. So you only have to ensure that the parameter is descriptive and it is in line with what the function is going to achieve. So I'm going to go ahead and write this as radius for the parameter. You can see that this kind of function is only going to have one parameter. So within the function definition is where we are going to go ahead and work on the expression that calculates the area of a circle. So the area of a circle is always pi r squared, meaning that we need the value for pi. And one thing you have to keep in mind is that you can always work with modules, and for you to work with the module, you always have to ensure that you're importing the module. So since we are not discussing modules at this point of time, we can just have the module imported. So the way you work with the module is by first of all accessing the import keyword and then the name of the module. So the value of pi is always accessed from the math module. So you go ahead and import math, and having you imported that module, first of all, for example, you can have a simple variable that is going to store the pi value by saying pi, then you go ahead and access the value from math.pi, or you can simply have a variable called result that is going to go ahead and store the whole result. So since the formula is pi r squared, you can have pi multiplied by the radius, then to the power 2. Or instead of working with the pi variable, you can just have this such that you go away with the first line in a way that you directly access the pi value from the module than storing it in the variable. So having created that, we can now go ahead and print the result for now. And we can also go ahead and customize it by saying that the area of a circle with radius, then we pass in the radius value, then we can go ahead and pass in the result, something like this. And having you created the function, you can go ahead and call the function, and ensuring that you are calling the function outside of the function definition. So you see that whenever you pass in parameters within a function and you try to access or you try to call the function, you're always given a hint that, hey, you do have a parameter, which is the radius, and the type is any. So in this one, you have to keep in mind that while we are creating this expression, we do expect a radius of type int. So it therefore means that we do have to pass in an integer, or it can also be a float value. It's very okay. So when we pass in 4, we can now go ahead and execute the program. So you see that we are having the output as the area of a circle with radius 4 is this much. So you can see that the output, the final output, is really long. So we can always have this formatted to some decimal places by accessing the colons and then dots. Then, for example, you can format this to 2 decimal places and go ahead and run the application. So the area of a circle with radius 4 is this much, and that means that we can also leave some space, or you can also work with some escape characters to achieve this. So in terms of this context, the value 4 becomes the argument of the function, and then the radius becomes the parameter of the function. So the arguments always depend on the number of parameters that have been defined within the function. So cases whereby you're trying to pass in more than one argument while we have only defined one parameter, what does this do? So let's try to rerun and access the functions. So you can see a type error that we are having, that the current function being called only takes in one positional argument, but it was given 2. So this will be updated to this. To summarize this up, we can also work with more than one parameter by making use of our current function, and instead of sum of numbers, we can just have this as add numbers, such that we add 2 numbers. For example, instead of defining these as local variables, you can just go ahead and pass them within the function parentheses such that they become parameters instead of the local variables. So having updated this, we can still keep the expression, and same applies to the output. And once again, we have to call this function such that it's executed. So the difference in this one is that we are working with 2 parameters, that is num1 and num2. And just like you can see the hint having hovered, is that both parameters take in any data type, but keeping in mind that we are currently performing an arithmetic operation, so you can either choose to work with an integer or a float. So in this one, I'm just going to keep these precise such that we do have something like a 90, and we can also pass in 10. And we can now go ahead and update this furthermore. So you can see that the output is the sum of 90 and 10 is this much. So in terms of return types, functions can always return values which can be of any data type, including integers, floats, strings, lists, dictionaries, and furthermore. So for example, let's say that you wanted to create a function that calculates the square of a number. So the first thing that you're going to do is defining the function and providing it with a function name, for example, square. And depending on the approach that you want to work with, you can choose to work with the parameter. So for example, let's say that the parameter is going to be a number, and you can go ahead and terminate. So for you to be able to work with the return type, instead of passing in the print statement, for example, or instead of working with a print function, you always have to work with a return keyword such that you return a value. So the first thing you do is to access the return keyword, and then in terms of this function, you have to go ahead and return the value. So that means that sometimes you can actually have a variable called result such that the result value is going to have the expression of the number, the expression value of the number to the power 2, such that we return the result. Otherwise, you can still copy the same expression and have the expression returned. So you just have to ensure that you're choosing the more efficient approach. So to ensure that you do have an output, you can, for example, have a variable like result that is going to store the value coming from this function, which is square. And since the function is having a parameter, that means that while calling the function, we do need to pass in an argument. So for example, if you wanted to find the square of 5, you go ahead and pass in 5 as the value or the argument. And having defined that, for you to see the output, you can work with the print function and pass in the variable result. So this only ensures that you do have an output. So you can see that the square of 5 is 25. And furthermore, there would also be cases whereby instead of working with a parameter, you just want to ensure that you are working or you are actually getting the number from the keyboard. So this can be updated to approach 2. And instead of passing in the parameter, we can have this kept empty, such that you go ahead and define a variable called number that is going to prompt the user to enter the number by working with the input function. and the prompt string having a value like enter a number. And then you have to know that whenever you work with the input function, the type of the value returned is always a string. So that means that we have to go ahead and cast this to either an integer or to a float, depending on the primitive data type that you want to work with. So for now, I can have this casted to an int such that we return an integer. Okay, so we can actually first of all comment this out such that we call approach 2. And by calling approach 2, that means that you're going to go ahead and access this function called square approach 2. And now you can see that this function is not having any parameters. That means that we cannot pass in any arguments. But according to this hint, you can see that the arrow function here is returning an int value. So when you look at this function, the fact that we are having a return statement, that means that we can, one, have a simple variable that is going to store the result, such that we just go ahead and print the result for now. And having done that, you can go ahead and rerun the program. So you can see that when I run the program, I'm prompted to enter a number. So if I enter 5, you can see that the output is 25. So in terms of functions, you can always assign default values to the function parameters. So if the argument is not provided when the function is called, the default value will be used. So for example, let's say that you wanted to create a function that returns the word Python. So the first thing that you're going to do is defining the function, and then the function name is Python name, such that for you to be able to work with the default values, you can always have a simple parameter, for example name, such that you assign the parameter value to the name of Python in this case, and then you go ahead and access the colons. Then you can print this out as the name of the parameter that has been defined, which is name. And having created that, for you to be able to call the function, the fact that we do have a parameter which is default, that means that you can choose to call the function with some function arguments, or you can just call the function without any values or any arguments. So in this one, you're going to go ahead and test the approach by accessing the function name, and you can see that the default argument that was passed in initially is Python. So the first approach, I'm going to go ahead and run the program, and you can see also for this one, you can go ahead and first of all comment these other calls out. So you can see that when I run the function, automatically we are having the output because of the fact that we do have a default argument value. So in addition to this approach, you can also call the function with some different argument. So for example, instead of Python, you can just go ahead and pass this in as, for example, you can work with programming. And having created that, you can retest the program. So you can now see that we are having the value or the argument updated to programming. So still with functions, you can always define functions that accept a variable number of arguments using the arg syntax. So for example, let's say that you want to calculate a sum of numbers. So the first thing that you're going to do is defining the function and then assigning it a name like sum numbers. And in this one, you have to go ahead and ensure that you are passing in the parameters in a way that, one, you access the asterisk operator, and then you pass in the parameter. And in this one, you can pass in parameter as numbers, and then you can go ahead and terminate. Then we can work with the return type such that we just work with the sum function that is going to find the summation of the numbers that are going to be passed in. So we pass in the variable or the parameter as the numbers. So having created that, I can actually first of all comment out the function calls for these other functions. And for us to see the output, we can work with a simple print function that is going to go ahead and call the function some numbers. So while calling the function, you can always pass in a number of arguments, having worked with the syntax above. So you can just go ahead and pass in arguments from, I think we can start with 1 up to 5. So having created that, you can go ahead and test the program once again. And now you can see that the output is 15. So in terms of keyword arguments, you can always define functions that accept keyword arguments using the keyword arguments syntax. So the first thing that you can do, for example, is, let's say that you want to create a simple function that greets. So you can go ahead and define a function def, and the function name can be greet. And in this one, the fact that we do want to work with a number of keyword arguments, that means that the first thing that you have to do is, for example, passing in parameters. So we can have the name, and then we can also greet you with the age, and we can also work with the city. And then you go ahead and access the colons. And then within the function definition, you can go ahead and print some customized output. For example, hello. Then we can pass in the name. So hello, then the name. Hello, then from. So like hello Goreti from Kampala. So that means that we can pass in the city. And after this, we can also pass in an exclamation mark, and then we go ahead and talk about an age. So you are, then you go ahead and pass in the age, then plus years old. So having created the statement that is going to be outputted, we can now move out of the function definition and go ahead and call the function. So to call the function, you have to access the function name, which is greet. And when I go ahead and pass in the parentheses, you can see that we are already having the ability to work with a number of keyword arguments. So that means that, one, we do have the name, the age, the city. So for us to work with this, since we are having the keyword arguments, we can just create this precisely in a way that the first thing you do is to access the keyword argument, which is name. And for example, if the name is Joan, and then you go ahead and pass in a comma, then the age, access the age, and so the age is at least maybe an integer. And then lastly, the city, such that the city can be something like Kampala. And having created that, we can go ahead and test the program. So you can see that we are having hello John from Kampala, you are this much old. So to summarize this up, let's look at the Lambda functions. Lambda functions are small anonymous functions that can take any number of arguments, but they only have one expression. So the syntax for Lambda functions is that you always access the Lambda keyword, and then you pass in the parameters, then you follow this up with the expression that the function is going to use. So for example, let's say that you want to create a simple Lambda function that is going to calculate a number by 2. So the first thing that you have to do, for example, we can have a variable that is going to store the whole result. For example, double of the numbers, such that we assign the variable the expression of the Lambda output. So you go ahead and access the Lambda keyword first, and then if we are to multiply a number by 2, that means that the parameter that we need in this one is going to be 1, which is the number. And then you go ahead and work with the colons. And then in terms of the syntax, we have to provide this with the expression. So the expression is going to be the number multiplied by 2. And once that has been created, we can now go ahead and get the output by accessing our variable. And when you access the variable, since this is now going to be a function, you have to then go ahead and pass in the arguments. So for example, we want to work with 10. So whenever I work with a lambda, that means that this is now going to be a function. So having worked with this lambda keyword, this now makes our variable a function, and we can now go ahead and access and actually test this. So the output is 20. So just a more summarized example of whatever we have covered. We can also calculate, for example, the area of a rectangle. And regarding the area of a rectangle, you can either choose to work with parameters or not. You go ahead and access the def keyword such that you define the function, and then the function name, which can be calculate area. And to calculate the area of a rectangle, that is going to be the length multiplied by the width. That means that this function is going to perform its task with parameters like the length and the width. So you therefore have to go ahead and pass in parameter variables for the length, and same applies to that of the width. Otherwise, you can also pass in L and W in terms of the names, depending on whatever you want to work with. And having created that, you can choose to work with a return type. For example, in this one, you can just have a return of the whole expression, which is going to be the length multiplied with the width, and such that we can now go ahead and call the function by accessing the function name. And you can see that we must provide the length and the width, and these are going to be now the arguments. So in terms of this, we can have the length of 10 and then the width of 5. And if we are calling this function, the fact that it is returning a value, that means that at least we also have to ensure that we are having a variable that is going to store the returned value. And having created this, you can go ahead and print out the final result by saying that the area is this much. Now you can go ahead and pass the whole result. Then you can also choose to work with some global variables to store the argument values, like 10 for the length, and then for the width you can have this assigned to 5, such that instead of working with these, you go ahead and pass in the length, and you can go ahead and pass in the width, such that instead of having the area is this much, you can say the area of a rectangle, the area of a rectangle with length this much, you pass in the length variable, and the width, then you go ahead and pass in the width variable is this much. So since it is the area, we can just say is this much, then we can have this customized to square units. So having updated that, we can now go ahead and run our program and have this executed. So you can see the output is that the area of a rectangle with length, I think it's better if we say of length this much and width. So the area of a rectangle of length 10 and width 5 is 50 square units. And also, if you do not choose to work with the parameters, that means that you can have the same function performing the same task such that you do not pass in the parameters. That is, if the parameters were not required, you just go ahead and leave these empty. Then either you can choose to work with a keyboard or not. That is, if you want to prompt the user to enter values of the length and the. So for that case, you can just copy what we had in here. Otherwise, you can work with static variables like the length, such that you assign the length to 10, and then the width, such that you assign the width to 5. And also, the fact that we do have these variables defined globally, that means that you do not have to redefine them. We can still make use of these variables and go ahead and call our function by copying this up and commenting this out, such that you go ahead and pass this in here. And since we do have to call the function, I'm just going to copy this here and paste the area here, such that this is uncommented, and then this is going to be area 2, such that with area 2 we pass in the length and the width. But now when you look at this function, we do not have to pass in any arguments, so this is going to be empty, such that it only works with these global variables and passes in those values within the expression, and then it goes ahead and returns the result. And that means that on line 105 we have to comment this out for now, such that we focus on the second approach. So you can see that we are having the area of a rectangle of length 10 and width is this much. So same applies if you really wanted to update the length to something else and then the width to something else. And this is our output. So that's all for today's video. I hope you found this very insightful. Thanks for watching, and see you again in the next session.